Hey, my name is Mike Stackhouse. I'm the Chief Innovation Officer at Atorus Research, and today I'm going to talk to you about our package Tplyr. So to walk you through a little bit of what Tplyr is. Tplyr we intend to be a grammar of data format and summary. So when you are going to do the data preparation steps necessary to perform clinical safety summaries, there's a lot of redundant syntax that goes into this. So Tplyr is designed to help you abstract away a lot of the redundant summarization syntax and focus more on the summaries that need to be performed. So what this actually looks like is that you have a table, and let's think about a demographics table. A demographics table is made up of the summation of a number of different variables, and really these are discrete variables and continuous variables. If we think of sex is discrete variables, you can break it down into categories, and what you're doing in these summaries is counting the number of subjects that fall into each group of sexes, and then you're representing some proportion of the number of subjects within the treatment group. On the other hand, age is a continuous variable. So we're going to perform descriptive statistics on that variable, such as n, mean, median, standard deviation, counts of missing. So when you start breaking this problem down and you add more variables into the mix, you're either going to be counting or performing descriptive statistics. So Tplyr also packs in a number of other features to it as well. There's easy construction of the table data using intuitive syntax that we've written. There's some smart string formatting for the numbers that makes it easy for the user to specify exactly how you want your numbers printed on the page. And there's a great deal of flexibility in what is performed and how it's presented without specifying hundreds of parameters. We wanted to make this thing easy to use, and that was a big thing for us. What you get out of Tplyr is going to be a data frame. And we did this intentionally because there's wonderful table packages out there in the R ecosystem that make it very easy to present your data, and they're worlds ahead of where we'd be in a long time. So you have GT, and that's being talked about a lot at R and Pharma, and there's been workshops on it, and there's plenty of content for that online. And then there's other packages like Huxable that we favored in the past, with our other package, Pharma RTF, when you're going to create RTF reports. Talk a little bit more about that later, but to get a sense of what Tplyr actually does, it's going to do your data preparation. So as I mentioned, we break things down into layers, and we have three types of layers that we've created. There's count layers where you're summarizing a discrete variable. An abstraction of the count layer is shift. If you're familiar with shift tables, you're going to summarize the change in state. So you have the baseline, and then at some time point, you're going to summarize what the change in state when subjects are flowing from categories like low at baseline to normal or high where you're above the normal ranges. And then we have descriptive statistics, which you can perform a number of different summaries, and we have a number that we've built in, performing things like mean, standard deviation, median, so on and so forth. So let's get into some examples. We've created an RStudio Cloud environment for you to work in, and that is available through our GitHub page. And if you go to the Atorus test drive on Atorus Research, Atorus test drive, we have a link to the RStudio Cloud instance and some links to our packages. But let's look at what we have here. So if I go ahead and knit this document, and we'll walk through it step by step. So let's look at creating a demographics table. So the first thing that you're going to do is instantiate your Tplyr table object. So here we're going to use ADSL, and I do want to mention what we're using for the data, and we have some abbreviated data sets that we've put into the test drive folder, and these are derived from the Fuse Test Data Factory replication of the data from the CDISC pilot, which you might have heard about. Back in 2007, CDISC prepared an example submission package, and it really gave us this wonderful data package that you can use in the pharmaceutical industry if you're trying to test and demonstrate packages that work on pharmaceutical data. And in 2019, Fuse released this data again in modern CDISC standards, SDTM 3.2 and ADAM 1.1. So we've abbreviated some of this to make the data sets smaller and easier to work with in unit test examples. But we have ADSL. The next thing that you're going to do is specify a treatment variable. So we're going to use TRT01P for the plan treatment, and then we're going to subset that just to the safety group with safety flag equals Y. So the first thing I'm going to do, if I want to summarize sex, I'm going to add a count layer to do summarize the discrete variable. So I specify my target variable, that's going to be sex, and then if I want to create a row label, I can provide a string. So here I have sex and percent in the by parameter. You can also use variables in the by parameter as well if you want to use data-driven row labels, and we'll see an example of that later. The next thing that I'm going to do is add a layer for age for descriptive statistics. So I'm going to have age, and then I'm going to do age years as my row label, and then I do the same for age group, and I do the same for race. Um, this assembles and creates the environments that are going to hold the summaries. And then the next thing that you could do is you build the summaries. So this build function carries out all the data calculation, and we have a lot of metadata that's still stored in this T object. But what build returns to you is a data frame. And I'll do some styling on that just to get it nice and pretty for our Markdown report. And I get this data frame back. So as I mentioned, this is just a data frame. You can do the styling with whatever package you want, be it Huxtable cable, which I'm using in the context of this R Markdown report, GT, and there's many more. But so I have the row label column. As I mentioned, these are things that I specified using my by variable. Row label 2 for count layers, that's going to be the discrete groups that are being summarized. So I have F for female, M for male. When I get into the descriptive statistics, the row label is going to hold the summary that's being performed. Same goes on for age categories and race, as I see down here. And then the var1 columns, and it's var1 because you are able to summarize multiple variables with descriptive statistics layers, and then I'll create a var2 and a var3, or however many you provide. But then I have this by treatment group. So you provided the TRT01P up in the table. Those treatment groups will append into your treatment column names that I have here. And then we have some order variables that help control sorting that we'll discuss in a little bit more later. So I get my pretty formats of ends and then percents and the means and the descriptive statistics. I have here mean and standard deviation. So there's 2 summaries being performed on a line here, 2 here, and 1 here. I'll explain a little bit more about that in a second. And that goes on for the other layers. But we do see some problems that we have here. And the sorting for the age categories is not in the correct order because it goes from less than 65 to greater than 80 to 65 to 80. And then I only have 3 races. But let's imagine for a second that I want to correct some of these things. So let's spell out the sexes explicitly instead of having male or M for male and F for female. Let's fix the ordering for the age categories, and let's assume that we want to show a few more races for which we didn't have any subjects in the data that we're summarizing. So I can handle this with a little bit of pre-processing. So I can fix the male and female and expand out the words using the recode function from Tplyr. In my factors, factors can drive a lot of really great things within Tplyr. So what I do here, I'm actually covering 2 things. For race, I'm adding in additional groups that didn't exist in my data. Those levels will be picked up and represented, and then I'll get 0 rows for those missing groups that I was not able to summarize. And that I can also use to correct the ordering of my age group variable. Now, another thing about Tplyr, if you have n variables, like a visit has a visit n, if you have an n variable, that can also just happen automatically from your data to control the sorting, and it can pick up that order for you. But if it doesn't exist in the data, or if you want to plug in missing values, an easy way to do that is to pre-process and just add in factor variables, and then those factor levels will be picked up for you. So here I'm going to use the same table creation code that I used from before, and then I can see that these things have been resolved in my data. Female and male are spelled out explicitly, and then my age groups are in the correct order, and then I have the 0 rows for groups that did not exist within the race variables that I had in there as well. Note that I did not do any sorting. Tplyr does not automatically sort your data on the back end. We leave that to you to use something like dplyr arrange if you have a custom sort that you want to implement. And then I'll give an example of that in a moment when we explore another table type and why we don't want to do that for you necessarily. So let's change things up a bit now and show how Tplyr can give you more control over the data that you're summarizing. So let's use sex as a column variable instead of a row variable so that we want to present by treatment group by sex. in our columns. Let's also switch up the summary statistics that are being performed on age and take out the percentages in all of the count summaries. So we're going to change two things with presentation, and let's add a total group. So we're going to create that table again, and now I'm going to use calls equals sex. So that's going to add in an additional column for us. And if I want to add in a total group, so often we see summaries that are presented by treatment group, but then we additionally add in a total group to show us our overall population, we can use the function add total group. You can also add in additional grouped treatments if you want to see something like treated versus placebo using the add underscore treat underscore group function. And if so, there's hierarchies to how you can control the presentation. So I'm not going to go into this explicitly, but there's defaults. You can set table level control. So all of the certain layer type, you can set the control over how you want to be how you want it to be presented. And then you can also have layer control over how you want to present data. And it always goes from the most narrow scope out. So layer control of your formats will override table control, and table control will override the default control. And you can read more about this on our package website where we detail some of this stuff. And I'll show you those links at the end here. But I'm going to set count layer formats that will work across the table, so I specify it in one place. So here I'm going to specify my counts as just I want to see 2-digit integers. And then I'm not going to show the percents. And note that this XX, when I specify an XX, that's saying that I want to provide 2 spaces for this number. On the right side of a decimal, it'll control the decimal precision. So if we go down further into adding the descriptive statistics layer for age, I'm going to do the same thing as before, but now I'm going to specify the format strings. So here I have my row label specified on the left side of the equals, and I'm providing this in the set format strings argument. So this left side of the equals will control the row label that will be presented in my data. And then I use the f-string call, and these f-string calls drive a lot of power behind the presentation of the information in Tplyr. So this is how we take and make a lot of assumptions over what you're doing. And I recommend that you read the documentation to get a better understanding of this. But for right now, I'm just going to walk through it. What I have here, this piece here is the format string that I want to present. So the X's will give me a specific number of spaces that I want to allocate on the left and right side of a decimal. But here, if I use A's in descriptive statistics, what that does for me is trigger auto precision. So Tplyr will look at your data and look at what the information you have as collected. So that's something that we commonly do, especially when you're looking at lab parameters. You want to present the data to the precision that it was collected. You can apply caps to it so that it doesn't go to 10 decimal places if you had some rather detailed numbers within your data. But the A's will trigger, it'll look at what factor of 10 you have on the left side of the decimal, so you allocate the proper number of spaces there, and on the right side you can specify as collected. Another thing that we commonly do for specific summaries is increment and add decimal places for higher precision for different tests. So like standard deviation, you might want to add additional spaces. So here I can use A plus 1. So we have A.A and A.A plus 1, so mean will be presented to the collected decimal precision, standard deviation to the collected plus 1. And then I'm going to do Q1, median, and Q3 and specify all of those to plus 1 decimal precision. And this is also showing you that this is how you can present descriptive statistics on the same line. So instead of presenting the descriptive statistics all in different rows, you can control what descriptive statistics you're presenting on the same line. I'll follow through and I'll create the age categories and the race additionally as other layers, and then I'll build my table again, and you can see the changes in the output now. So I have 76 and 8.7 for my mean and standard deviation, then 70, 78, 84 for my Q1, median, Q3. So those summaries you can see have changed now. And then for age categories and race, you can see that the percents are no longer there. So that demonstrates the descriptive or some control over over the layers. But let's get a little bit more advanced here to show a little bit more of what Tplyr is able to do for you and some of the more of the work that we've put in. Adverse event tables are an example of another type of count summary that has some other nuance to it. So one thing that I'm going to demonstrate here is that two variables can be counted together in a nested fashion. So in adverse event tables, it's common that you're going to look at your body system and then adverse events that occurred within that body system. So you're going to look at the body system and then the preferred term nested together. But you still want to see the counts in the body system. So both of these groups will be summarized, but the second variable, when you use the vars argument for your target variable, is nested within the first. So we'll see how that works in a second. Additionally, for adverse events, we're sometimes more interested in the number of subjects who experienced an adverse event. So we want to see distinct counts by subject instead of the total number of counts. But you also might want to see the total number of event counts. So that's what we're going to look at here, presenting distinct and non-distinct counts of adverse events together. And then there's some other variables that we'll demonstrate here that work with sorting and how you can pull out specific information to sort by from the counts that you're deriving. And then also let's look at how Tplyr can apply risk difference. So let's walk through this step by step. So we're going to create the table example again. We're going to use ADAE now and TRTA as the treatment variable. Then we're going to set the population data. So we're going to set the population data as ADSL, and then we're going to set the population treatment variable that we can merge back into ADAE with using TRT-ONA. So why do we want to do this? Well, to get your big N, to get the actual size of your treatment group within the population, you're going to need to look back at the ADSL data set because ADAE only has records for subjects who had adverse events. So when you're looking at these subsets within a variable, not every subject might have had that occurrence, so you're going to have to be careful about how this is derived. So then we're going to add the count layer. Like I mentioned, now we're going to have use the vars argument to specify two variables in our count layer as the target variables. So we have AE BODSys for body system and AE decode for preferred term. Now I'm going to set distinct by and then for usubj ID. So now the counts of AE decode will be distinct by the subject ID, and then the big N's for the treatment group are being pulled from ADSL within that treatment group. So I'm going to specify my format strings now. So I'm going to do the distinct percentage, and then the event count. So note here that I'm able to specify those three different fields. So I have distinct percent, and then N specified, and I'll get distinct percent, and then the event counts in the brackets, which is a common way that you might see adverse events presented. I can make sure that I only have one row label column using the set nest count equals true. So this is just something for presentation. And let's talk about sorting for a moment. A common way to sort adverse event tables could be by descending occurrence of looking at the descending occurrence of an adverse event within a specific treatment group. So you're going to want to look at the actual counts that are being summarized. In this case, we're going to look at the distinct N variable. So we want to have available for sorting the number of subjects who had an adverse event, and then I'm going to specify that I want to see that within the xanamyline high dose. So what this does is the order variable that's created for this layer is going to extract out that variable for you so that you can, when you do your sorting, it's represented by that you can sort it by descending occurrence of, or by descending number of subjects who experience that adverse event within the xanamyline high dose treatment group. And that'll be a little bit easier to understand when we look at the data. And then I'm also going to add some risk difference calculations. So I'm going to want to see each of the treatment groups compared to placebo. And then finally, I'm going to build the table. I have suppressed warnings on here because the risk difference calculations are going to trigger some warnings because there's not enough data for it to be statistically significant when you have low counts of adverse events within some of these groups. So I'm going to mask away those warnings. And note that for risk difference, our implementation at the moment is using the prop.test function from baseR, but we plan to expand that out in some future updates to our package. I'm going to grab the columns and just make sure that I have everything grouped together the way that I want it, and then present the table. So what we have here, I have my outer body system, so skin and subcutaneous tissue disorders. And then I'm going to have the specific adverse events that occurred within that body system. So here I have the counts. I have distinct n, distinct percent, and then the event counts, and that goes on for each of these. Now I mentioned the order variables. So right now I'm actually using the same method for the body system and the preferred term, but you can set them as different methods as well by providing two arguments into the set order count method right here. So I could say by factor, by count, and then that would order alphabetically for the a BODSIS variable, and then by counts for the preferred term. You can read more about that in our sorting vignette to get some more details on that, as we know that's rather complicated. And then you can see here that's going to pull out by count. So the xanamyline high dose, we had 42 subjects who had adverse events within that body system, and that's poured out for ord layer 1, which associates with the body system. In the within the ord layer 2, which is associated with the preferred term, you can see 1 here. Xanamyline high dose had 1, 0, 0, 1, 1. So what this is doing for us is allowing us to pull distinct counts out of this area so that we can use them to sort by. Which gives us a lot of flexibility over how you're able to order your table on the back end. And you can see here we additionally have the risk difference calculations, which is going to give you the difference and then the 95% confidence interval low and high. You have full control over those arguments that you pass into the prop test function in the add risk diff function so that you can pass those forward. But by default, it'll give you the difference, and then 95 low, 95 high. And then the last example that I want to take a look at with you today is shift tables, as this is another common type of table that you'll see in safety data. So what a shift table allows us to do is look at the change in state. So the first thing that we want to do is look at those variables so that we have BNRIND and ANRIND. Now, these variables, you might not have all of the changes in state for each by group that you want to look at. So this is something that you might want to do the pre-processing for it to set those levels. So you can set the order of it as well to control your sorting. So you can set the low, normal, high for each of those variables. And we convert them to a factor. So within each of the groups that we summarize, each of those groups will be presented so that we can get that nice little matrix by treatment group. So we're going to set subset here to param code equals creatine kinase so that we can have a little bit less data to look at in these tables, which can get quite long, but I'm going to use ADLB and TRTA. I'm going to add a layer, so I have group shift, and then I'm going to use the vars argument. So this is very similar to the count layer API. What I'm going to do is have the vars argument to specify my row variable, which I'm going to use the baseline, and then the column variable, which is the analysis endpoint that we're going to look at. And then I want to look at this. I can now use the by variable, and I can put variables into that. So if I want to look at these, if I want to summarize this by visit and parameter, I can specify param and visit, and then those control my row labels here on the left. So I built that table, and then you can see row label 3 becomes the values of BNRIND. So I have low, normal, high, and then in my columns here, I have low, normal, high by treatment group. So here, what I can see if we look within this little block from within placebo for these 3 columns, I had 11 subjects that were normal at baseline. I had 12 subjects that were normal at baseline, and then I can also see that one of those subjects was normal at baseline, but at week 12 for creatine kinase had a high or had a high normal, or was the normal range, it was above normal range, which is what the H marks. Thank you again for stopping by our booth here at our Pharma. It's been a really awesome conference and a really awesome opportunity for all who have been able to attend. There's a few more things that I want to just step through and recap before I end this. So up here on GitHub, you can find all of the examples that I walked through today, and we have a link into an RStudio cloud project so that you can go and test drive this for yourself. So be sure to check that out so that you can get some hands-on experience. Also be sure to check out our booth for Pharma RTF. That's our other package. Eli Miller is available there so that you can go through and see what this package has to offer you as far as outputting RTF documents from packages like Huxable and GT available. Check out the package research down page for more information on what Pharma RTF or for what Tplyr can do for you, and learn more through the documentation there as well. And for more examples of using R to produce outputs based on CDISC data, we have the CDISC pilot replication where we replicate all 30 outputs from the original CDISC pilot using the Fuse data factory data that I shared with you today. And then just again, check out the package website. We have Pharma RTF available to you as well. And I want to call out the Fuse standard analysis white papers. We based a lot of our design for Tplyr based on these. So that they have a white paper on adverse events, demographics, disposition, and medications tables, and measures of central tendency as well. If you want to talk about Tplyr, reach out to me at mike.stackhouse@atorusresearch.com. I will be available throughout the R-Pharma conference. We can stop in the room together. I can walk you through. I can show you more about what Tplyr can do. I'm going to expand on anything that you have questions on. You can also follow me on Twitter at Mike at Atorus, and add me on LinkedIn at linkedin.com/in/Michael S. Stackhouse. Thank you very much for your time today. I appreciate it, and I look forward to talking with you.